So we're going to prove that this, all of this, equals 0. So you're going to focus on the left-hand side and hope that eventually that left-hand side is going to come out to be 0, and then we prove that this is true. So we only focus on one side, and obviously in this case it's going to be that left-hand side. And we're going to use these two identities. They're useful because this, look, cos A minus B can be used to rewrite this bit, cos of y minus pi. And this can be thought of as two separate angles, A and B, so I can use this identity to rewrite that one. So the first step is to rewrite this and this using these. So I'll just pause while you do that. Use these two compound angle formulae, here and here, to rewrite these two terms. So left-hand side is what we're focusing on, and you're going to write down what that is. It can be quite long. So hopefully you ended up with this. If we look at this one, A is y and B is pi, so I can rewrite this, y and pi, and same for the other one. So we do that. Now, what we do now is remember what these are in terms of the wave. So what I want to do now is just to sketch the sine wave underneath. Think of this now in terms of pi. Remember we mentioned earlier, one complete revolution, 360 degrees, or in terms of radians, 2 pi. So this is 2 pi radians. That's pi. And I have that in my mind. And if you do a lot of these things, that's useful for you to have that in your mind too. And this is a sine wave. We know it's a sine wave because it starts at 0. I could write a similar wave for the cosine. But the cosine, if you remember, starts at 1, goes down and up to 1. So the cosine wave looks like that. Again, that's one complete revolution. So that's 2 pi. And this is pi. If you don't remember those things, you can always put in, if you've got your calculator, you need to be in radians, because these are all in radians, you can work out what the cosine of pi is. But if I've got this on my mind, I know what the cosine of pi is. It's this value here. And this, because remember I said these are units, the amplitude is 1, this is plus 1, and this is minus 1. That's plus 1, and this is minus 1. So the amplitudes go between plus 1 and minus 1. So without even using the calculator, I know what the cosine of pi is. It's minus 1. So whenever I've got cosine of pi in here, which is this one, I can write that's minus 1. Now, if we look again at our waves, what's the sine of pi? According to this wave, what's the sine of pi? 0. So this is 0. In other words, this whole term is 0 because the sine of pi is 0. So that's gone. Now, what about this one? Pi over 2. Well, if that's cosine is pi, then this must be pi over 2, mustn't it? That's pi over 2. What's the cosine of pi over 2? 0. That's 0. So this whole term is 0. And what's the sine of pi over 2? There's the sine wave. That's pi. What's the sine of pi over 2? No, that's pi. Where's pi over 2? So it's there. 1, right. 1. So, in other words, we can write this. The left-hand side, that's minus 1, so that's minus, this bit becomes minus cos y. That bit, the side, that's all gone. In the next bracket, first term's gone, and this just becomes plus cos y. So it all comes down to that, minus cos y plus cos y. Look at it while you write it down, check you see it. But of course, minus cos y plus cos y is 0. So we proved it. The right hand side is 0. And so finally QED. Knowledge of waves, how they fit in with rotations, and these sines and cosines, compound angle formulae, allow us to make these sorts of proofs. Not easy the first time you do them, but the more you do, the easier it gets. And there are some in the text that you can have a go at, and then you should be able to attempt the one in the assignment.